Okay, so what we're going to talk about here is we're going to talk about carrier-mediated transport. And I talked about this a little bit when I talked about facilitated diffusion. Okay, so in carrier-mediated transport, what you have is you have a protein that spans the plasma membrane, and it assists the solute crossing. That's it. Now, the thing about carrier-mediated transport is it can be both passive, okay, or it can be active. Okay, so remember the definition is a passive means that there's no direct energy needed. And then active, you need direct energy in usually the form of ATP. Okay, so now the carrier-mediated transport has some characteristics. Okay, so the characteristics are: one, it is specific. Okay, a protein, just like an enzyme, it will only carry certain things. Okay, so just like the enzyme will only bind to certain ligands, same thing happens here. Okay, if you have a protein inside the plasma membrane, it will only work on certain things. So you have these things called sodium channels. Okay, those proteins will only work on sodium. You have things with potassium channels. Those things will only work on potassium. You have glucose channels. Those proteins will only work on glucose. So they're not interchangeable. They can be saturated. Okay, just like an enzyme can be saturated. Remember when we talked about enzyme? If I had an enzyme that can only work at one reaction a second, throwing more of the products in is not going to make that enzyme work faster. Same thing with this. If I fill up that channel, only a certain amount of things can go through the cell, through that channel at any given time, so I can saturate it up. And adding more of the thing that's going to be transported won't make it go any faster. The only way that I can make it go faster is to add more channels. And the third thing about carrier-mediated transport is it is regulated. And what this means is it can be turned off it can be turned on and off. Okay, so if I don't want, let's say for instance sodium, let's say that I don't want sodium to be able to cross the cell membrane, I close the channel. I've regulated the sodium in the cell. And if I do need sodium, I can open those channels up and the sodium will come into the cell. Okay, so that is the regulation. So let's just draw a little picture of carrier-mediated. And what we'll do is we'll use glucose as an example because there are special glucose receptors and channels inside of the cell. So what we're going to do here is I'm not going to double draw the cell membrane. Okay, we're just going to assume that you understand that it's a phospholipid bilayer and there's a bunch of stuff inside of it. Okay, now you've got, let's just say we got a protein that this looks like this. Okay, this is what this protein looks like. All right, and at the, let me fix this for a second. And at the bottom of this protein, there's this groove right there, that groove. Now let's just say that is a glucose receptor site. That is a glucose okay, and at the bottom of this there's a gate that keeps that closed when there's nothing in there. Now let's just say that I have glucose. We're going to say glucose is kind of shaped like this. Okay, so now if this glucose goes in, fits in there, fits in there, what that's going to do is it will open up the gate. The gate will open, and then the glucose can go inside of the cell. Okay. Now it's going to follow, most of the times it's going to follow if the glucose concentration inside of the cell is low, and let's assume that it is. Let's say glucose concentration is low and glucose concentration here is high. Okay, so this is extracellular, this is intra, and we're just using this for an example because typically glucose level is never mind. So the glucose level is high on the outside of the cell, and they're going to say that it's low inside of the cell. This is going to naturally just pass through, and we really don't need to expend any energy because it's going to get the energy from the environment, the natural movement of the cells. Okay, so facilitated diffusion, what we're showing here, this is facilitated. This is a passive process. Okay, that's passive transport. And the reason that it's facilitated is I have a glucose transporter, and that's what this green thing is. That's what this protein is. This is a glucose transporter. Okay, and that's all that is. Okay, so that's facilitated diffusion. Okay, and with that, we've gone through all of the passive processes that you need to know for me. There are several others, but I'm not going to dwell too much on them. And so now what we're going to do next is we're going to talk about the active transports. We're going to talk about active transports. So ones that have a direct source of energy. And we're going to spend time talking about the sodium-potassium pump. We're going to talk about endocytosis and exocytosis. And then after that, we're going to talk about co-transport, moving things in different directions. Okay, so it's pretty short, but it's a pretty simple subject. So active transport's next.